Dear students, in today's class we are going to explain clearly some numerical problems of NCERT Cbse 10th class physics electricity chapter, page number 193, question number 11 and question number 12 we are going to. Question number 11 first we see. So this is a question number 11. Show how would you connect three resistors each 6 ohms so that combination has resistance of 9 ohms and 4 ohms. So to get the resultant resistance 9 ohms, so 3 resistance of each one 6 ohms connected, how like? To get 4 ohms as the resultant resistance, 3 resistors having each one 6 ohm, how can you connect the circuit, whether series or parallel? So now we are going to solve this one. So question number 11, 3 resistors are given. R1 is 6 ohms, R2 is 6 ohms, R3 is 6 ohms. So first one, to get 9 ohms, the resultant resistance, to get 9 ohms the resultant resistance, R1 and R2 are connected in parallel and R3 is connected in series. So this is R1 and this is R2 and this is R3. R1, R2 and R3. So like that they are connected. These two are in series and this is in, these two are in parallel, this is in series. So this implies R1, R2 are in series, then 1 by in parallel combination. So in parallel combination, total resistance 1 by Rp is equals to 1 by R1 plus 1 by R2. R1 is 6, R2 is 6. LCM is 6. Then 1 plus 1, that is 2 by 3. 2 by 6. On cancellation, 1 by 3. So 1 by Rp is equals to 1 by R3. Then reciprocal we are taking, Rp by 1 means 3 by 1. This implies Rp is equals to 3 ohms. Now this Rp and R3. Now Rp and R3 are in series. So this implies total resistance R is equals to Rp plus R3, that is 3 plus R3 value is 6, that is 9 ohms. So likewise it is calculated. Next in the second case, to get the resultant resistance, 4 ohms, R1 and R2 are connected in series and R3 is connected in parallel. So like this is the structure. This is R1 and R2. So this is R1, R2, R3. R1, R2 are in R1 and R2 are in series, connected in series. R3 is in parallel. So in series combination, total resistance Rs is equals to R1 plus R2, which is equal to 6 plus 6, that is 12. So now Rs and R3 are in parallel. So this implies total resistance is equals to 1 by R is equals to 1 by Rs plus 1 by R3, 1 by 12 plus 1 by 6. LCM is 12, that is 1 plus 2, that is 3 by 12, 3 by 12. Reciprocal we are taking, 1 by R is written as R by 1. This implies 12 by 3, 3 ones, 3 fours. So R is equals to 4 ohms. So to get a 4 ohms the resultant resistance, 2 resistors are connected in series and third one is in parallel. So to get a 9 ohms as the resultant resistance, so 2 resistors are connected in parallel and third one is in series. So this is question number 11 in the exercises topic. So in the page number 193, NCERT Cbse 10th class science electricity chapter physics topic. So next to question number 12, what about we see now? Question number 12. Several electric bulbs designed to be used on 220 volts electric supply. So number of electric bulbs designed to be used on the voltage of 220 supply line. So and they are rated, means that their power is 10 watts. How many lamps can be connected in parallel with each other across the 2 wires of 220 lines? Maximum allowed current is 5 amperes. So how many bulbs can be connected in parallel between in the 2 wires of voltage 220 volts and power of each bulb is 10 watts. So when they are able to draw, the current is 5 ampere in the maximum limit. So we are going to calculate this one. Question number 12. Question number 12, page number 193. Page number 193. So potential difference or voltage is a given 220 volts. Power is a given 10 watts. And current drawn, maximum current drawn is 5 amperes. So we want to find number of bulbs which will be connected in a parallel 2 lines. Number of bulbs, so denoted by capital N. So using the formula of power, we have a formula, number of bulbs is equals to V into I by P. This implies N is equals to V value is 220, I value is 5 ampere, P value is 1. This is on 0 0 on cancellation. So we can get 22 into 5 by 1. So number of lamps or number of bulbs connected is N is equals to, that is 110. So this 110 lamps or bulbs can be connected in parallel. So on 220 volts of potential difference. So with the maximum limit of current 5 amperes. So that is in the next video we explain question number 13 and 14 students in the same page number in the exercises topic. That's all this is.